So what is data science? Data science is the field of study that deals with modern scientific techniques, statistical methods, and algorithms to derive insights from vast volumes of data. Companies using data science are very numerous. With companies generating data every minute, there is a need to make sense of this data. Mu Sigma, Fractal, Fidelity, Intel, Genpact, Qubela, Amazon, Trendince, Connect the Dots. Just about every business out there nowadays uses some form of data science, even if it's indirectly, to help govern their business and help them grow and compete in the business world. And we use the data science to find unseen patterns within the data, analyze and draw insights from our data, and solve business problems and make decisions. And the data science has a life cycle. We start with our data discovery. Then we go through data preparation, exploratory data analysis, data modeling, interpret the results, and back to data discovery. When we talk about data discovery involves asking the right questions, identifying the business problems, finding the best solution, and gathering correct data from relevant sources for analysis. This is, in the data science life cycle, the most important step. Now, in general, it only involves like a small percentage of the time you spend on this. But if you're not asking the right questions, you can't go in the right direction. Data preparation. Data preparation deals with cleaning the data, finding the inconsistencies, tackling missing values, converting it into the right format, and making it ready for analysis. When I'm running the data science life cycle, this is probably where the most time is spent. Data can be so messy. You have to break it down into different parts. You have to import the different pieces from different databases. Are you dealing with straight numbers off of spreadsheets and cells, or are you dealing with text documents and natural language tokenization? Exploratory data analysis. Analyze and visualize the data using different charts and graphs to find significant patterns and hidden trends. That helps to understand the data better. The building of the charts is very creative. Probably one of the more enjoyable parts is be able to come in there and describe the data and show that to the shareholders. Then we dive into data modeling. Use classification, regression, and clustering algorithms to build machine learning models that can help predict and forecast future trends. This is where we start getting into predictions. What's next? Where's it going to go? And then interpret the results. Validate the model results, draw the final conclusion, and check if the performance of the model is in line with the requirements. The final step is the one that you set up in front of the board members and give them suggestions as to what's next. Where are we going to spend our marketing money? Where are we going to start preparing our firefighters for the next fire breaks next year? What is the weather patterns coming in? This is where you interpret the results and say how accurate they are. Are they valid? Is it something we're going to keep, or are we going to throw it out and have to start over? When we look at data science components, there's the mathematics, statistics, domain expertise, data engineering, data visualization, and machine learning. When we sum this up in data science, really this point in all of this you want to focus on first is domain expertise. Now, when you're taking your classes, obviously you want to go through the mathematics, the statistics, the data engineering, the data visualization, the machine learning, and learning all those tools. But it really, in the job field, the domain expertise comes in. Because if you're really good with business and you go into business with these tools, then you're able to ask the right questions and deal with it. When we talk about the tools in data science and where they sit, there is a data analysis. Data analysis focuses more on statistics and mathematics, where the data science side focuses more on the machine learning, data visualization. And then there's database management, which really focuses on the data engineering part of it and how to manage that data and the data flow. And you can see all these components come together, and then they form the data science. And we talk about tools in data science. We have SAS, we have MATLAB, we have SQL. You have your Apache Spark, your R, Tableau, Python. Right now in the programming languages, Python is probably the most widely used, with R coming in a close second. The reason for that is these are both open source and anybody can use them. When we look at SAS and Tableau, those are two packages that are paid for which have a lot of automation behind them. So a lot of larger companies will pay for those packages because they help work out a lot of the back-end stuff before you even need to use them. And of course we have Apache Spark. You almost have to know Apache Spark and the growing data lakes today. That's your big data. How do you distribute this if you're going to process it over a large amount of data? When we look at data science applications, there's internet search, very common. You enter your Google thing and it uses the data science algorithms to figure out what to return. Voice assistants, analyzing the voice coming in and connecting it with whatever patterns they need to activate so you can ask it to turn your lights on in the living room. Healthcare, biggest field growing right now. How do we analyze health data from a smartwatch and figure out how to know when a disease is being spread across the world? Healthcare, how do we identify cancer versus non-cancer so we know who to prioritize and get them in for surgery where other people might not need that immediate care? And even identifying problems somebody might have with their health long before they even happen. What a neat thing to do instead of waiting till you have a heart attack to know months ahead of time that you're having heart conditions. Logistics, how do we get from point A to point B? If you ever look at some of the major distributors, they pre-ship things based on what they guess people are going to need. This way you get your stuff right in the mailbox the day after you order it. E-commerce, huge in there because you have to know what kind of marketing we're going to put out. Who are we selling to? What's our target audience? Robotics, one of the funner ones when you're coming up into the future is how do we automate the different tasks we have, from self-driving cars to manufacturing lines to maybe even a self-robotic chef in the kitchen. So when we talk about solving problems with data science, we have to ask possible questions and the desired algorithms. And these really are kind of an overview of some of the terminology you'll want to know in data science. So when we talk about that, how much or how many? We're talking about regression. Regression basically means a number. If you've ever seen stock charts, you see the guess at what the next sales price is or buy price is. That's all on your regression side. Is it A or B? Classification. Is that a dog or a cat that my photo took a picture of? How is this organized? Clustering. This is where we take things that look alike and put them together so that we can then make predictions on it. How different is this? Just like you have clustering, you have the opposite, anomaly detection. How do we find things that don't fit in? Where are the outliers? What are things we might need to look at that aren't in our model? And what to do next? Reinforced learning. This is probably the newest market, is how do we set something up where as the data comes in, it learns from the new data as to what the next action is going to take. Most of these are combined. So when we talk about regression, classification, clustering, anomaly detection, reinforced learning, a lot of times when you put your model together, you might have multiple parts of this. We might look at the clustering of data and then feed it into a classification. Is this a bad loan to make at the bank, or is this a good loan to give? And from there we might start looking at, when we start clustering these things as good and bad and what kind of setup is, we then might run it through a regression model to say, hey, what is the dollar amount this person should be allowed to take a loan out? And you can see that all of these start coming in, and then a lot of the models, reinforced learning, we talk about like bank loans and things like that, once a year they have to rerun those algorithms. And so that's like a human run reinforced learning. Now we're starting to automate that so that as the data comes in real time, the models start updating themselves. They start figuring out a way to solve new problems as they occur. And of course in robotics, reinforced learning is one of the biggest growing fields. Algorithms used in data science. Linear regression. Logistic regression. When you're looking at both of these, think numbers. We're talking regression models. And so linear regression figures out the best line through the data. Maybe it's looking for a curved line. Logistic regression starts looking at data on a continuum so that it goes to an exponential. You have a spot where it might be one or the other, and then you know what it is as it goes to one side or the other. Decision tree. wonderful tool. If you they used to call it a hack, now it's becoming mainstream, to look at the back end, what made the decision. So it's really easy to trace back to how you arrived at the decision. Decision trees are kind of nice that way. Nearest neighbors. K nearest neighbors is your clustering. K means clustering. Hierarchical clustering. So hierarchical starts dividing them and builds a hierarchy, where the K means and the K nearest neighbor look for things that kind of connect each other. How close are they in data format? DB scan, another form of clustering your data. Principal component analysis. So we start breaking up and looking at the different components in our data coming in. These are all algorithms used in data science, and there are more. These are kind of the mainline ones, and each one of these has many settings which you can play with to build a better model to predict your data and where you want it to go.
What are the prerequisites for data science? There are 3 essential traits required to be a data scientist. One is curiosity. You need to be able to ask questions. The first step in data science is asking questions. What is the problem you are trying to solve? If you ask the right question, only then you'll get the right answer. Very often, this is a very crucial step where a lot of data science projects fail because you may be asking the wrong question. And then obviously when you get the answer, that's not the answer you're looking for. So it is very important that you ask the right question. Needless to say, then the second part or the second trait is common sense. So you need to be creative. You need to come up with ways to use the data that you have and try to solve the business problem on hand. In many cases, you may not have all the data that you need. In many cases, the data may be incomplete. So that is where you need to come up with ways, what are the best ways to fill these gaps wherever this is missing. And that's where common sense comes into play. Last but not least, after doing all this analysis, if you're unable to communicate the results in the right way, the whole exercise will fail. So communication is a key trait for a data scientist. Maybe technically you may be a genius, but then if you are unable to communicate those results in a proper way, once again, that will not help. So these are the 3 main traits: curiosity, common sense, and communication skills. In a way, you can say these are the 3 C's. Okay, so what are the other prerequisites? The first one, so machine learning. Machine learning is the backbone of data science. Data science involves quite a bit of machine learning in addition to the basic statistics that we do. So a data scientist needs to have a good hang or need to be very good at data science. The second part is modeling. So modeling is also a part of machine learning in a way, but you need to be good at identifying what are the algorithms that are most suitable to solve a given problem, what models can we use, and how do we train these models, and so on and so forth. So that is the second component. Then statistics. Statistics is like the core foundation of data science. So you need to understand statistics and you need to have a good hang of statistics in order to be a good data scientist. And this will also help in getting good results. Programming is to some extent required. At least some program or the other would be required as a part of executing a data science project. The most common programming languages are Python and R. Python especially is becoming a very popular programming language in data science because of its ease of learning, because of the multiple libraries that it supports for performing data science and machine learning and so on. So Python is by far one of the most popular languages in data science. If any one of you is wanting to learn a new language, that should be Python. And then of course you need to understand databases, how databases work and how to handle databases, how to get data out of databases and so on. So these are some of the key components of data science. Now coming to the tools and skills that are used in data science. These are some of the skills from a language perspective. It is Python or R. And from a skills perspective, in addition to some of the programming languages, it would help if you have a good knowledge or good understanding of statistics. And what are the tools that are used in data analysis? SAS is one of the most popular tools. It's been there for a very long time. and that's the reason it is very popular. And however, this is compared to most of the other tools, it is a proprietary software, whereas Python and R are mostly open source. The other tools are like Jupyter Notebooks. You have RStudio. These are more development environments and development tools. So Jupyter Notebooks is a interactive development environment. Similarly, RStudio is for performing or writing R code and performing analytics and performing data analysis and machine learning activities you can perform in RStudio. It has a very nice UI, and initially R was not so popular primarily because it did not have user interface, and RStudio is a relatively new addition, and after the advent of RStudio, R became extremely popular. And there are other tools like MATLAB, and of course some people do with Excel as well. As far as data warehousing is concerned, some of the skills that are required are ETL. So in order to extract data and transform load, ETL stands for extract, transform, load. So you have data in the databases like your ERP system or a CRM system. You need to extract that and then do some transformations and then load it into your warehouse so that all the data from various sources looks uniform. Then you need some SQL skills, which is basically querying the data, writing SQL queries. Hadoop is another important skill, especially if you're handling large amounts of data. And also, one of the specialities of Hadoop is it can be used for handling unstructured data as well. So it can be used for large amounts of structured and unstructured data. Then Spark is an excellent computing engine for performing data analysis or machine learning in a distributed mode. So if you have a large amount of data, the combination of Spark and Hadoop can be extremely powerful. So you store your data in Hadoop HDFS and use Spark as your computation engine. It works in a distributed mode similar to Hadoop in like a cluster. So those are excellent skills for data warehousing. And there are some standard tools that are available like Informatica, DataStage, Talent, and also AWS Redshift if you want to do some on the cloud. I think AWS Redshift is again a good tool. Data visualization tools. For data visualization, some of the skills that would be required are, let's say, R. R provides some very good visualization capabilities, especially for developing during development. And then you have Python libraries, Matplotlib, and so on, which provides very powerful visualization capabilities. And that is from skills perspective. Whereas tools that can be used are Tableau is a very, very popular visualization tool. Again, that's a proprietary tool, so it's a little expensive maybe, but excellent capabilities from a visualization perspective. Then there are tools like Cognos, which is an IBM product which provides very good visualization capabilities as well. And then coming to the machine learning part of it, the skills required there are Python, which is more for programming part, and then you will need some mathematical skills like algebra, linear algebra especially, and then statistics and maybe a little bit of calculus and so on. And the tools that are used for machine learning are Spark MLlib and Apache Mahout. And on cloud, if you want to do something, you can use Microsoft Azure ML Studio as well. So these are by no means an exhaustive list. There are actually many, many tools and probably a few more skills also may be there. But this gives a quick overview, like a summarization of the tools and skills. Now, moving on to the life of a data scientist. What does a data scientist do during the course of his work? So let's see. So typically, a data scientist is given a problem, a business problem that he needs to solve. And in order to do that, if you remember from the previous slide, he basically asks the question as to what is the problem that he needs to solve. So that is the first thing. He has got the problem. Then the next thing is to gather the data that is required to solve this problem. So he goes about looking for data from anywhere. It could be the enterprise. Very often the data is not provided in the nice format that he would like to have it or we would like to have it. So first step is to get whatever data that is possible, what is known as raw data in whatever format. So it could be enterprise data, it could be, there is probably a requirement to go and get some public data in some cases. So all that raw data is collected. And then that is processed and analyzed and prepared into a format in which it can be used. And then it is fed into the analytics system, be it a machine learning algorithm or a statistical model, and we get the output. And then he puts these output in a proper format for presenting it to the stakeholders and communicating those insights or the results to the stakeholders. So this is a very high level view of like a day in the life of a data scientist. So gathering data, raw data, performing some quick analysis on that, and maybe processing or manipulating this data to bring it into a certain good format so that it can be used for the analysis, feeding this into that analysis system that has been designed, be it mathematical models, machine learning models, and then get the results, the insights, and then present it in a nice way so that the stakeholders can understand. How about machine learning algorithms? So let's see what are the various machine learning algorithms that would be required for a data scientist. So these are a few of the algorithms. Again, this is not an exhaustive list. We have regression is one of the supervised learning models or techniques. So in case of regression, you try to, let's say, come up with a continuous number. So the difference between regression and, let's say, a classification is that in case of classification, those are discrete values. Whereas here we are talking about regression where let's say you are trying to predict the temperature, which is a continuous value, or the share price, which is a continuous value. So that is regression. So you need to know what is regression, how to perform regression, and we need to understand clustering. So clustering is one of the unsupervised learning techniques. In this case, there is no label data that is available, and you get some data and then you want to put this into some shape so that you can analyze it and you try to make sense out of it. Let's say you have, one example is you have a list of cricketers and they have not been marked as bowlers and batsmen or all-rounders or whatever, right? So you just have their names and maybe how many runs they scored, how many wickets they have taken, and so on. But there is no readily available information saying that, okay, this person is a batsman, this person is a bowler, and so on. So I'm talking about cricket. Hopefully, most of you are familiar with the game of cricket. So how do we find out? So then we put this into a clustering mechanism, and then the system will say that, okay, these are the people who have all scored good amount of runs. So they belong to one cluster. These are all the people who have taken good amount of wickets. So they belong to one cluster. And maybe here are some people who have taken good amount of wickets and they have made good amount of runs. So they may be belonging to one group. And then we take a look at it and then we label them as, okay, people who have all together and those who have, scored many runs, we label them as batsmen. People who have taken a lot of wickets, we label them as bowlers, and people who have taken good amount of wickets and also made some good runs, we label them as all-rounders. But the system will just say, okay, this is cluster 1, cluster 2, cluster 3. The names we human beings have to give the names. Now, decision tree is used for what is known as classification. Primarily, it can also be used for regression, but by and large, it is used for classification. And here again, it's a very logical way in which the algorithm goes about classifying the various inputs. One of the biggest advantages of decision tree is that it's very easy to understand and it's very easy to explain why a certain object has been classified in a certain way compared to maybe some of the other mechanisms like, say, support vector machines or logistic regression and so on. So that's the advantage of decision tree, but that is also a very popular algorithm. Then we have support vector machines primarily for classification purpose, and then we have naive Bayes. This is again a statistical probability based classification method. So these are a few algorithms. There are a few more that are not listed here, but there are some more algorithms as well. And by the way, there are detailed videos about each of these algorithms available. You can check in the playlist. So now let's talk about the life cycle of a data science project. Okay, the first step is the concept study. In this step, it involves understanding the business problem, asking questions, get a good understanding of the business model, meet up with all the stakeholders, understand what kind of data is available, and all that is a part of the first step. So here are a few examples. We want to see what are the various specifications, and then what is the end goal, what is the budget, is there an example of this kind of a problem that has been maybe solved earlier. So all this is a part of the concept study. And another example could be a very specific one to predict the price of a 1.35 carat diamond, and there may be relevant information inputs that are available, and we want to predict the price. The next step in this process is data preparation, data gathering and data preparation, also known as data munging, or sometimes it is also known as data manipulation. So what happens here is the raw data that is available may not be usable in its current format for various reasons. So that is why in this step, a data scientist would explore the data. He will take a look at some sample data, maybe pick, if there are millions of records, pick a few thousand records and see how the data is looking. Are there any gaps? Is the structure appropriate to be fed into the system? Are there some columns which are probably not adding value, may not be required for the analysis? Very often these are like names of the customers. They will probably not add any value or much value from an analysis perspective. The structure of the data, maybe the data is coming from multiple data sources and the structures may not be matching. What are the other problems? There may be gaps in the data. So the data, all the columns, all the cells are not filled. If you're talking about structured data, there are several blank records or blank columns. So if you use that data directly, you'll get errors or you'll get inaccurate results. So how do you either get rid of that data, or how do you fill these gaps with something meaningful? So all that is a part of data munging or data manipulation. So these are some additional subtopics within that. So data integration is one of them. If there are any conflicts in the data, data may be redundant. Yeah, data redundancy is another issue. There may be, you have, let's say, data coming from two different systems and both of them have customer table, for example, customer information. So when you merge them, there is a duplication issue. So how do we resolve that? So that is one. Data transformation. As I said, there will be situations where data is coming from multiple sources, and then when we merge them together, they may not be matching. So we need to do some transformations to make sure everything is similar. We may have to do some data reduction. If the data size is too big, you may have to come up with ways to reduce it meaningfully without losing information. Then data cleaning. So there will be either wrong values or null values, or there are missing values. So how do you handle all of that? A few examples of very specific stuff. So if there are missing values, how do you handle missing values or null values? Here in this particular slide, we are seeing three types of issues. One is missing value. Then you have null value. You see the difference between the two, right? So in the missing value, there is nothing, blank. Null value, it says null. Now the system cannot handle if there are null values. Similarly, there is improper data. So it's supposed to be numeric value, but there is a string or a non-numeric value. So how do we clean and prepare the data so that our system can work flawlessly? So there are multiple ways, and there is no one common way of doing this. It can vary from project to project. It can vary from what exactly is the problem we are trying to solve. It can vary from data scientist to data scientist, organization to organization. So these are like some standard practices people come up with. And of course, there will be a lot of trial and error. Somebody would have tried out something and it worked and will continue to use that mechanism. So that's how we need to take care of data cleaning. Now, what are the various ways of doing, if values are missing? How do you take care of that? Now, if the data is too large and only a few records have some missing values, then it is okay to just get rid of those entire rows, for example. So if you have 1 million records and out of which 100 records don't have full data, so there are some missing values in about 100 records. So it's absolutely fine because it's a small percentage of the data. So you can get rid of the entire records which have missing values. But that's not a very common situation. Very often you will have multiple, or at least large number of a data set. For example, out of million records, you may have 50,000 records which are like having missing values. Now that's a significant amount. You cannot get rid of all those records. Your analysis will be inaccurate. So how do you handle such situations? So there are again multiple ways of doing it. One is you can probably, if a particular values are missing in a particular column, you can probably take the mean value for that particular column and fill all the missing values with the mean value, so that first of all you don't get errors because of missing values, and second, you don't get results that are way off because these values are completely different from what is there. So that is one way. Then a few other could be either taking the median value, or depending on what kind of data we are talking about. So something meaningful we will have put in there. If we are doing some machine learning activity, then obviously as a part of data preparation, you need to split the data into training and test data set. The reason being, if you try to test with a data set which the system has already seen as a part of training, then it will tend to give reasonably accurate results because it has already seen that data, and that is not a good measure of the accuracy of the system. So typically you take the entire data set, the input data set, and split it into two parts. And again, the ratio can vary from person to person, individual preferences. Some people like to split it into 50-50. Some people like it as 63.33 and 33.3 is basically 2/3 and 1/3. And some people do it as 80-20. 80 for training and 20 for testing. So you split the data, perform the training with the 80%, and then use the remaining 20% for testing. All right. So that is one more data preparation activity that needs to be done before you start analyzing or applying the data or putting the data through the model. Then the next step is model planning. Now these models can be statistical models, this could be machine learning models. So you need to decide what kind of models you're going to use. Again, it depends on what is the problem you're trying to solve. If it is a regression problem, you need to think of a regression algorithm and come up with a regression model. So it could be linear regression. Or if you're talking about classification, then you need to pick up an appropriate classification algorithm like logistic regression or decision tree or SVM, and then you need to train that particular model. So that is the model building or model planning process, and the cleaned up data has to be fed into the model. And apart from cleaning, you may also have to, in order to determine what kind of model you will use, you have to perform some exploratory data analysis to understand the relationship between the various variables and see if the data is appropriate and so on, right? So that is the additional preparatory step that needs to be done. So a little bit of details about exploratory data analysis. So what exactly is exploratory data analysis? It's basically to, as the name suggests, you're just exploring. You just receive the data and you're trying to explore and find out what are the data types and what is the data clean in each of the columns. What is the maximum minimum value? So for example, there are out of the box functionality available in tools like R. So if you just ask for a summary of the table, it will tell you for each column, it will give some details as to what is the mean value, what is the maximum value, and so on and so forth. So this exercise or this exploratory analysis is to get an understanding of your data. And then you can take steps to, during this process, you find there are a lot of missing values. You need to take steps to fix those. You will also get an idea about what kind of model to be used and so on and so forth. What are the various techniques used for exploratory data analysis? Typically, these would be visualization techniques, like you use histograms, you can use box plots, you can use scatter plots. So these are very quick ways of identifying the patterns or a few of the trends of the data and so on. And then once your data is ready, you've decided on the model, what kind of algorithm you're going to use. If you're trying to do machine learning, you need to pass your 80% the training data, or rather you use that training data to train your model. And the training process itself is iterative. So the training process you may have to perform multiple times. And once the training is done and you feel it is giving good accuracy, then you move on to test. So you take the remaining 20% of the data. Remember, we split the data into training and test. So the test data is now used to check the accuracy or how well our model is performing. And if there are further issues, let's say, and model is still during testing, if the accuracy is not good, then you may want to retrain your model or use a different model. So this whole thing again can be iterative. But if the test process is passed or if the model passes the test, then it can go into production and it will be deployed. All right. So what are the various tools that we use for model planning? R is an excellent tool in a lot of ways, whether you're doing regular statistical analysis or machine learning or any of these activities. R, along with RStudio, provides a very powerful environment to do data analysis, including visualization. It has a very good integrated visualization or plot mechanism which can be used for doing exploratory data analysis and then later on to do analysis, detailed analysis and machine learning and so on and so forth. Then of course you can write Python programs. Python offers a rich library for performing data analysis and machine learning and so on. MATLAB is a very popular tool as well, especially during education. So this is a very easy to learn tool. So MATLAB is another tool that can be used. And then last but not least, SAS. SAS is again very powerful. It is a proprietary tool and it has all the components that are required to perform very good statistical analysis or perform data science. So those are the various tools that would be required for or that can be used for model building. And so the next step is model building. So we have done the planning part. We said, okay, what is the algorithm we are going to use? What kind of model we are going to use? Now we need to actually train this model or build the model rather so that it can then be deployed. So what are the various ways or what are the various types of model building activities? So it could be, let's say in this particular example that we have taken, you want to find out the price of 1.35 carat diamond. So this is, let's say, a linear regression problem. You have data for various carats of diamond and you use that information, you pass it through a linear regression model or you create a linear regression model which can then predict your price for 1.35 carat. So this is one example of model building. And then a little bit details of how linear regression works. So linear regression is basically coming up with a relation between an independent variable and a dependent variable. So it is pretty much like coming up with equation of a straight line which is the best fit for the given data. So like for example here, y is equal to mx plus c. So y is the dependent variable and x is the independent variable. We need to determine the values of m and c for our given data. So that is what the training process of this model does. At the end of the training process, you have a certain value of m and c, and that is used for predicting the values of any new data that comes. All right, so the way it works is we use the training and the test data set to train the model and then validate whether the model is working fine or not using test data. And if it is working fine, then it is taken to the next level, which is put in production. If not, the model has to be retrained. If the accuracy is not good enough, then the model is retrained, maybe with more data, or you come up with a newer model or algorithm and then repeat that process. So it is an iterative process. Once the training is completed, training and test, then this model is deployed and we can use this particular model to determine what is the price of 1.35 carat diamond. Remember, that was our problem statement. So now that we have the best fit for this given data, we have the price of 1.35 carat diamond, which is 10,000. So this is one example of how this whole process works. Now, How do we build the model? There are multiple ways. You can use Python, for example, and use libraries like Pandas or NumPy to build the model and implement it. This will be available as a separate tutorial, a separate video in this playlist. So stay tuned for that. Moving on, once we have the results, the next step is to communicate these results to the appropriate stakeholders. So, which is basically taking this results and preparing like a presentation or a dashboard and communicating these results to the concerned people. So finishing or getting the results of the analysis is not the last step, but you need to, as a data scientist, take these results and present it to the team that has given you this problem in the first place and explain your findings, explain the findings of this exercise and recommend maybe what steps they need to take in order to overcome this problem or solve this problem. So that is the pretty much once that is accepted, and the last step is to operationalize. So if everything is fine, your data scientist presentations are accepted, then they put it into practice and thereby they will be able to improve or solve the problem that they stated in step 1. Okay, so quick summary of the life cycle. You have a concept study, which is basically understanding the problem, asking the right questions, and trying to see if there is enough data to solve this problem. And then even maybe gather the data. Then data preparation, the raw data needs to be manipulated. You need to do data munging so that you have the data in a certain proper format to be used by the model or our analytics system. And then you need to do the model planning, what kind of a model, what algorithm you will use for a given problem, and then the model building. So the exact execution of that model happens in step 4, and you implement and execute that model and put the data through the analysis in this step, and then you get the results. These results are then communicated, packaged and presented and communicated to the stakeholders, and once that is accepted, that is operationalized. So that is the final step. Now in the end, let's take a quick look at the demand for data scientists. Data science is an area of great demand. The demand for data scientists is currently huge and the supply is very low. So there is a huge gap. So what are some of the industries with high demand for data scientists? I think gaming is definitely one area where it's a industry which is consumer facing industry, and a lot of people play games and growing industry, and it requires a lot of data science. So that is an area where data scientists are in demand. Then we have healthcare. For example, data science is used for diagnosis and several other activities within healthcare, predicting, for example, a disease. So healthcare is definitely finance, definitely banks, insurance companies, all of these, there is a huge demand for data scientists. Marketing is like a horizontal functionality across all industries. There's a demand for data scientists there. Then, of course, in technology area. So pretty much all of these areas, there is a lot of demand. Globally, there is a huge demand. So this is a very, very critical skill that would be required currently as well as in the future.